distributor training, advanced training, distributor advanced training, ion exchange. The softening exchange process. Hardness in the influent water stream passes through a resin tank and the ion exchange resin bed. The calcium and magnesium and iron are exchanged for sodium. When the resin has no more sodium, the softening exchange process must be reversed. This process is called regeneration. Good system design means minimal regeneration, optimal production, lowest salt use, and consistent soft water delivered to the customer. An example of how softening with ion exchange resin, sodium-based softening takes place. We start off with calcium in the water, and we have two sodiums attached to R stands for the resin bead. And what happens is, as this reacts, we give up 2 sodium atoms for every 1 calcium that comes in, which is now bound to the resin bead. So what happens is, before tap water, you have high levels of calcium, magnesium, and after, you're left with potassium and sodium in the water, but nothing's changed on the anion side, and that's important to understand. We are only removing hardness minerals on this side, or metals that are more preferentially exchanged than sodium and potassium. The exchange process. Water softener resin is regenerated with sodium chloride, salt. What softeners will remove from water? In this order, water softeners will prefer to remove aluminum, barium, strontium, copper, iron, manganese, calcium, and magnesium, in that order. Softeners remove cations by this selectivity. So if these ions that aren't in bold are present in the water, they get pulled off first. They'll even push off a calcium that's already on there and send it farther down the resin to be picked up by another bead farther down. So this selectivity is important to understand if we have troubled waters where it's difficult to regenerate, that we can remove these things we wish to remove. Cations with the higher charge are removed first, and they're held more tightly. So it takes, to remove aluminum from cation resin, we need to regenerate with more salt, because it takes more of these guys to push this big guy off the king of the, that they're playing king of the hill. It takes a lot of these guys to push this guy off the hill. Or it only may take 1 or 2 to push calcium and magnesium off that hill. It takes a lot more sodium to push these guys off the resin. Single softening tanks versus twin softeners. Single tanks have the pros of having a smaller footprint than their twin their twin siblings. They're less expensive on startup because there's less equipment to purchase. The cons: we must design this system and size it for excess capacity, because we do not want to deliver hard water to our customers ever. So we have to take 10 to 30% of the capacity of this resin bed to compensate for fluctuations in hardness, because water softeners are metered by how much water goes through them, not the hardness that goes through them. So this unit could regenerate at any given point in time during a day where it's gone through the amount of water it needs before it regenerates. So you could end up having a store being delivered hard water for an hour and a half or more, during this regeneration cycle, impacting all their beverages and equipment. And when you add that up over time, that may impact equipment operation as well. And you don't get to use the full capacity of this resin. Remember, you've got 10 to 30% of this resin that you do not get to use as a safety factor. A twin softener, the pros, they're much more efficient use of water. 100% soft water all the time goes to the customer because when the first tank exhausts, it just switches tanks and regenerates this one. So the second tank is always ready to provide soft water whenever the customer needs it. There's less salt usage because you use the full capacity of the tank, not 10 to 30% less in a single mode. So the lower total cost of ownership is lower with a twin system. For the same sort of efficiency or water use, this system would have to be 10 to 30% larger to deliver the same sort of efficiency out of this sort of system. Cons: it's larger, has a bigger footprint, and there's more upfront cost. Sizing water softeners. There's 6 steps to this process. A, we need to test the water hardness. We need to know how much hardness we have to remove. Secondly, we need to know what side of pipe size we're dealing with, whether it's the incoming pipe size in the building, if we're going to do whole house water softening, and if it is just for the hot side, we need to understand what water supply we're dealing with going to that hot water heater so we can match the size of the plumbing to the softener. This is important because flow meters for softeners are based on the size of the plumbing going in and out of them, and how they pick up water flow is based on that. And also the kinetics, the flow kinetics, the contact time of the water with the resin beads is also based on that incoming plumbing water supply and the amount of water going through the softener. You undersize the softener too much, you may go from 2-inch plumbing down to 1-inch, and that'll create a rather large restriction in your overall plumbing system. So we want to match the softener to handle the flow of the plumbing getting to it so that it passes through it smoothly and doesn't cause significant pressure drop or issues, and then it's able to actually perform its function as a water softener. Then we need to determine how much water they use daily so we know how much hardness they're going to need to exchange during that day. From that information, from the hardness and the water usage, we're able to calculate the amount of resin we need to satisfy that. And then we choose a tank configuration based off of those numbers, whether it's single or twin based on the customer's needs. And then we select a water softener from there. Making water testing easy. Water testing is important for operations that sell filtration. If we do not understand what's in the water, we cannot provide the correct solution for that water. Imagine if your doctor only saw you over the phone and prescribed medicines without doing any tests or ever seeing you, just based on a conversation. That's what a lot of people take the approach to water treatment. If we don't understand the patient, the water, what we need to treat to get it into a healthy condition for the equipment, we can't do that. Well, there are several ways to do water testing. They go from quick, cheap, and easy and less accurate to much longer delays in time and extremely accurate. Well, test type. How do you get it? Well, there's dip strips, catalogs, pool stores, MROs. When should I use those? When you have a need for very, very quick turnaround. But understand that these are ballpark tools. Very quick and easy to use. But in order to read these, A, you have to match up color pads, and the ranges are quite broad, so there's a lot of ambiguity in being able to read those test strips and get accurate results. Plus, water changes, quality changes frequently, and these can also go bad sitting in a vehicle in the hot sun. SmartWorks test, you have to sign up at everpure.com to get enrolled in the SmartWorks program and order the test kits. Once you use this, when you need that support program to back you up in helping determine what is wrong with the water and understanding that water report in a way you can hand a customer. The positives about this, it provides a detailed report and they're more accurate. The test strips associated with SmartWorks are quite a bit more accurate, but you must make sure of the expiration dates. Those are valid tools. You do not want to use chemistry testing equipment that is expired. You will get false results, and if you specify equipment off of false results, you will get a false specification. Negatives, you must be registered in order to get onto this program. And the last and most accurate is a laboratory test. How you get these? You call your regional sales manager, or look at our catalog, page 2, and I'll have a part number where you can order a test kit. When should you use this? A detailed customer and to support a program. This will provide the most accurate information to share with the customer. It's third party. There's no arguing necessarily with the results, and it seems fair and balanced. It's very accurate, and it's specific to that customer's site. The negatives is expense and lead time. There is an expense with this, and it takes time to collect a sample at a location, ship it to us, where we will ship it off to the lab. The lab will take 4 to 10 days to process a sample depending on their workload. And then you have to factor in the time it takes to get the sample from a technician or on site to your place of business to get it boxed up and shipped to us here before that 4 to 10 day lead time starts. So we typically tell people 2 weeks or longer depending on their speed of response. Your regional can help you make the right call on what tests to use, and technical service can help you as well. Sizing softeners, flow rate versus pipe size. Mechanical engineering and plumbing companies typically choose the pipe size knowing the total demand of a store. So they understand that and they design the plumbing to handle that flow. Well, the plumbing size must match the softening pipe size so that we do not impact flow rate and pressures being delivered to all the equipment. And as you can see, from a 1-inch pipe to a 2-inch pipe, we quadruple the water flow. So this is an exponential curve in how much water flow a piece of plumbing can handle. So you jump more than 50% going up a 1/4 inch. And you go up a 1/2 inch, you more than double the flow rate of a pipe can handle. So this is very important. If you put a 1-inch softener on a 2-inch line, you've gone from the possibility of handling 80 gallons a minute down to 21 gallons a minute, and you've just essentially turned all the 2-inch plumbing downstream of your water softener into a 1-inch pipe, because this is all the water you can push through. That 1-inch softener is going to go through this line. Doesn't matter how big it is back here. It could be 3 feet. You will still not get any more out of that softener than 21 gallons per minute. Determining total usage. We have databases and assumption tools to help size a softener. Hot and cold side, hot only. In most commercial applications, you're going to be dealing with hot only. Very rare cases would you want to do hot and cold, and I would suggest consulting with your RSM or our regional operations manager before deciding to do whole house hot and cold softening. Full service restaurants. Gallons per day per cover, 4 gallons. Restaurant with bar, that's 5 gallons. So you can take the number of their seats they have times 5, and then the number of turns they have on those seats to get the average water use. Hotel, 65 gallons per day per room. How big of a hotel is it? You get your number right there. Hospital, 170 gallons per day per bed. So you're able to use these tools and get the right amount of water that they're using in a given day so you can size this. Now, resin required is calculated by taking the gallons per day times the gallons per minute times the hours of operation. So they have an 11 gallon per minute flow demand times 60 minutes times 16 hours of operation. They use 10,560 gallons per day. Well, we take our hardness in grains per gallon and multiply that by grains per day. And this will give us the grains consumed throughout that day. So at 17 grains per gallon, at 10,560 gallons per day, we need to be able to exchange off 179,520 grains per day. So we take that grain amount, minimum size, we would need a 7-foot cubic softener to handle that much water at a 9-pound. 9-pound regenerations are the most efficient salt usage level for capacity and minimizing salt use. So we would have to have a 7 cubic foot resin tank or 2 3.5-foot tanks that regenerated more often, matched to the plumbing size. Safely would go to a 10 cubic foot resin, which would give us a day and a half before the system would regenerate. You could go to a 20 cubic foot resin softener, and it would regenerate every 3.5 days. Choosing a tank size, single tank. For food service operations, we have calculators that will calculate desired hardness, recommend a model, and show daily hot water use energy savings. A full-service restaurant with 1,000 covers per day at 17 grains per gallon hardness, calculated usage of 5,000 gallons per day, we get a softener that's a CES 2900M, 239,000 grain capacity, metered 7 cubic foot softener. Choosing a twin tank. Same restaurant. And what we come up with is a CES 9500, smaller individual tank but twin. Each tank is 135,000 gallons grain, 135,000 grain capacity, and this is a 4 cubic foot per tank system, a full 8 cubic feet. But the thing about this is we're using all of that resin, not a safety factor that was calculated in the previous software. If you notice here, we have a 29% energy savings factor in using this software. And we get that same energy savings with a single softener. The only difference between the two is how often they're going to regenerate and how much salt and water they're going to use doing so. So a bit of review. We need to know water chemistry, the hardness, how much iron's in the water helps as well, pipe size, so we can determine the flow rates we're dealing with, hours of operation, how often is this going to need to run to do its job, utility locations, do we have water, power, and drain, and can we get this thing through the door to get it into the building? Without water being at the location of the softener, without power being there, without a drain being there, all those utilities will have to be provided for the location. So it's good to choose a location for your water softener where you have access to all three of these. And if you only have access to two, make sure you pick the best combination of two. Drain can be problematic if it's a long run. You may have to run a bunch of extra plumbing to get to a drain properly, and that has to be done well. Entryway, doorways. Some of these large softeners have massive brine tanks that will not fit through a standard door entry. So you may have to use a man door or a couple different brine tanks in order to match salt use. Dimensions. Will the softener fit in the room? Very important before you sell a water softener. Do you have the space for it? Cation exchange softener removes hard ions, calcium, magnesium, ferrous, dissolved iron. Be exchanged with sodium, potassium, and this is how it works. Example, feed water of 20 degrees hardness, which is 356 ppm. You put in this amount of calcium plus this amount of carbonate, you get the total amount. Sodium exchange, we get 378 total TDS. If you use potassium, you get 493 total TDS. There is a slight elevation in TDS when using a softener because we are putting 2 sodiums in for every calcium. And this increases the conductivity of the water, which shows up as TDS. This is normally not a significant increase. Weak acid cation softening. This is done instead of having a resin that exchanges sodium off for hardness minerals. These resins give up hydrogen or acid. Semi-softening process removes calcium carbonate, but preserves these other minerals that we wish to leave in. And it does this by, if you notice, before we had the resin bead with 2 sodiums here, Na. Well, now we have 2 hydrogens. Hydrogens in this form are acid. So as we push exchange off the calcium, we give up 2 acid molecules, and this is given to the water. So we've partially softened the water, removed some of this hardness. Okay, what went back in here? Well, now we have those 2 hydrogens are now able to interact with the bicarbonate buffer system, or the alkalinity, and it reacts with 2 of those HCO3s to produce 2 molecules of carbon dioxide and 2 molecules of water. So what you end up with is dissolved CO2 that will bubble and gas off. Reduced hardness and lower alkalinity. And if we lower this enough, we can remove all this HCO3. Raw water sample, to use or not to use weak acid cation exchange resins, or Claris. Well, note the pH. We have a good high pH. We have plenty of TDS in the water, lots of bicarbonate too. So there's plenty of stuff to remove, and we have plenty of hardness here to remove, so we can remove this out and lower this. But there are a couple other things here that we want to note. The chloride level. Chloride is corrosive, and the lower the pH goes, the more corrosive this becomes. And bicarbonate buffers this corrosion, so as we're removing this, this becomes more corrosive as well, even without a pH drop. Hydrogen softening technology without a blending bypass. So you would get all of that removed, but you'll get a significant pH drop because of this acid and its interaction with chloride in the water, which keeps it from gassing off and being converted to H2O. What happens is you get a possible pH range of 4.3 to 5.0 at 12 degrees of hardness or 120 ppm and zero bypass. So you've now gone from water that was neutral to very acidic that's now going into your ovens or whatever application. That is going to be a corrosive situation that which will damage equipment. So you have to be careful on application. You can see this is a water sample after going through a wax resin. We've lowered the TDS by 200 ppm, but note the pH, 5.4 from 7.8. That's a factor of 3,000 times more corrosive, more acidic. And notice the chlorides haven't changed. We've reduced the bicarbonates almost down to nothing. We still have some hardness left. You know, it's doing its job here. We're reducing the bicarbonates. TDS reduction, fantastic. It's doing its job. Chloride hasn't changed. pH much more acidic. So this is a case where wax resins would not be recommended because they would be creating a corrosive environment rather than softening the water and creating a more ideal range TDS-wise for our equipment and beverage applications. Clarus Ultra is hydrogen softening plus some sequestering. So what happens is we're able to function at a lower bypass setting, remove alkalinity to a point where which we want to. We've lowered both of these, dissolve CO2, but we don't get as much of a pH drop because we're removing less. We're not adding as much acid back. So we get a pH of greater than 6.5 at a 60% bypass here. And that's due to the buffering of the agent that's included in this resin that prevents that pH from dropping. It's actually the buffer like Tums, but it's not part of this system. It's separate, so it's able to do its job and inhibit, scale, and buffer the water from corrosion. And here's how it works. We have partial reduction of hard ions by hydrogen softening. Get that removed here, plus 2 hydrogen. Then there's sequestering of the residual hardness by a very tightly controlled phosphate feed. So we sequester the rest of the calcium, keep it out of harm's way. And you can see we have 142 milligrams of calcium beforehand, plus 214 milligrams of carbonate. We have 356 milligrams of TDS. And we go through the bypass setting. We've reduced it from 142 to 85, from 214 to 128. With 1 milligram per liter of phosphate, we've dropped that TDS down to 214, well within a coffee spec and our hardness specs for those applications. pH characteristics of Clarus Ultra 15 versus volume. As you notice, here's the test water coming in. The test water varied more greatly than the water coming out. This shows the pH control that is pH stabilization and control that's capable with Clarus Ultra when it's selected properly. Claris versus Claris Ultra. Claris should be used on drip, coffee, espresso, and tea brewing equipment, paying mind to corrosion factors. Combi steamers and ovens using boiler systems without high chlorides and silica in the water. Also can be used on direct spritz, but you absolutely must make sure that you have chlorides within the manufacturer's spec before you do. Claris Ultra, drip coffee, espresso, tea, and tea brewing equipment, and small ice making equipment. And this is because we do not wish to feed phosphate in direct injection steam applications. You could use Claris Ultra on a boiler-based steam application, but boiler-based steamers are few and far between these days. Competitive comparison between the two. Claris Ultra has many more benefits and positives associated with it than our competitors. We can adapt the system and stabilize the pH. The other systems cannot. We can inhibit corrosion. They cannot. Metal migration inhibition. We provide that as well, and they cannot. Scale reduction, yes. Most of them can provide some built-in bypass. Ours uses a duo blend technology, very, very accurate. Other competitors have no bypass. Some have a bypass that does not function very well, and others have the IntelliBypass system mimicking Claris. Have flexible heads. We have multiple heads for the Claris. Our competitors only have a single head. We have a quick change cartridge. Only one of our competitors has a quick change cartridge, which allows you to vary size of cartridge depending on your needs and can grow with your customer. Ours has a built-in carbon block. It's an excellent carbon block, better than our competition. Chlorine and organic retention, excellent on this carbon block, better than our competition.